On example 3 here, we're going to identify extraneous solutions. We're going to find out that an extraneous solution is kind of like sort of a weird thing to describe. It's sort of like a solution that you arrive at algebraically that works when you follow the algebra. However, there's something in the process that doesn't work, and you kind of find out when you check it. So let's go through the steps and kind of see that without that kind of vague explanation I just gave. So if we start here, square root of x plus 21 equals 3 minus the square root of x. If I want to solve this, I have my original equation, I'm going to square both sides. When I square 3 minus root x, I end up with 3 times 3 is 9. Square root of x times the square root of x is, sorry, negative square root of x times negative square root of x is x squared. No, it's not, sorry, it's just x, right? So we're saying square root of x times square root of x. Mistake. Okay, just x. And then we'll have 3 times negative x, we'll have negative 3 root x, and we'll have another negative 3 root x. We'll have negative 6 root x. If you want to see that a little more carefully, you can always create an area model where you do 3 minus root x on both sides, and you take a look at what those 4 areas are and what they simplify to. So they will simplify to x minus 6 root x plus 9. Okay, so now next step is we want to isolate the radical. So we've got x on both sides, right? So we can just lose the x on the left and the right. We can subtract by x. We got 21 and 9, so let's take away 9 from both sides, and we'll end up with 12 being negative 6 root x. Okay, dividing both sides by negative 6, we get negative 2 equals root x. We get 4 equals x. Okay, so this is the part where I said algebraically we can go through and we can get an answer. 4 is the solution to this. However, look what little strange bit of thing happens when we actually put 4 back into the equation. So I'm going to erase what I got here, scroll down a little bit. If I put 4 back in the equation, like I said, okay, I solved it. So like if I put this back in, it should work. I mean, that was the number that we got. Okay, but look what we get actually. We get 4 and 21 makes 25, so we get 5. Square root of 4 being 2. We get 3 minus 2 is 1. So we have 5 equals 1. That's not right. Okay, well, it isn't right. It's not right. The result does not satisfy the original equation, so it is an extraneous, I'm going to abbreviate that so you don't have to watch me slowly write letters. Extraneous solution. Therefore, there is no solution. So you might notice at one stage we get right here. This is where the problem came from. When we got to negative 2 equals the square root of x. So negative 2 equals the square root of x is not true. There is no square root of a number that is negative, not in the real number system anyways. Now, if you're familiar with the imaginary number system, then you'd say, okay, well, the solution is like, you know, it involves i's, it involves imaginary units. But we're talking about real number system right now. So we are just saying that this is kind of a no-go. You're not going to take a square root and get a negative number. Now, there is some stuff you could look at here and you could say like, well, you know, we didn't need 3 minus 2. Square root of 4 has 2 solutions, right? The other solution is negative 2. 2 negatives would have made a positive and we would have got a correct answer. Okay, so how do we describe this? We kind of say that like if we're going through the steps and we get a solution, so we got our solution was 4, but then we put our solution back into the equation and that answer does not make the equation work in all cases. So maybe in some cases where we take a certain square root, it works, but it does not work in all cases. Then this is what is considered an extraneous solution. It's a solution that actually like doesn't always work when we put it in. There's a version where it works and there's a version where it doesn't. The version where it works is where we have the negative square root here. To the same extent, we could also say like, well, square root of 25, it's not just 5, right? It's also negative 5. And if we had a negative 5 here, there's really no way that we're going to get to negative 5, no matter if we take the positive or negative square root there. So there's all these different like kind of outcomes. There's one particular one that does work. That was when we kind of manipulated things, so it was 3 plus 2. But every other combination of possible values for these square roots didn't work. So we give this vocabulary term an extraneous solution. Okay. We'll move on to example number 4 next.